Okay, this is question 5 of homework M3, and in this question we've got a particle P projected from A going to C, going through some parabolic arc. It's initially projected with a speed of 32 meters per second, and we've got an angle alpha here, where sine of alpha is 3/5, and we need to find the time of flight from A to C, the distance O to C, the speed of the particle as it's passing through B, so speed is a scalar quantity, and the angle that the velocity of P at B makes with the horizontal. So imagine a tangent to this arc at this point here. Okay, so with all these projectile type questions, the way forward is always to split this component into its horizontal and its vertical components, or to split this velocity rather into its horizontal and its vertical components. So we'll start doing that first. We'll look at the vertical velocities and then we'll look at the horizontal velocities. So the vertical velocities will allow us to calculate the time of flight from A to C, and the distance from O to C. We'll find this distance once we know the time of flight and once we know the horizontal component of the velocity. So the problem looks like this, and this is the first thing that we do. We split this velocity here into its horizontal component and its vertical component. And if sine alpha is 3/5, then imagine a 3, 4, 5 triangle. So there's alpha down there. Sine of alpha is 3/5, and this must be 4, which obviously now means that the cosine of alpha is 4 divided by 5. So this horizontal component here, V horizontal, is the cosine of alpha, which is 4/5 times 32. 4/5 times 32. And the vertical component, V vertical, is the sine of alpha times 32, and the sine of alpha is 3/5, so it's 3/5 times 32. And these give us 19.2 and 25.6. So we need to find, the first part of the question was to get the time of flight from O, which is this point here, to C, and all we're really interested in here is the vertical component. We assume obviously the horizontal component is just constant all the way across and there's no air resistance. So what we're interested in is the time this particle takes to rise to the apex up to here, and then to fall back down to C. So we look at our equations of motion. We'll look at the initial speed, the final speed, the acceleration, the displacement, and the time. Now for the displacement, what we'll do is we'll set a datum. We'll assume that this line along here at O is basically our datum, where we measure all the displacements from. We'll imagine all the velocities going up the way are positive. So our initial speed, the initial vertical speed, is the 19.2 positive going up the way. We don't know the final speed. We know the acceleration is going down, so it's minus, and it's 9.8. And we know that the displacement is minus 20. We're trying to find the time, so we want the equation of motion that links displacement, initial speed, and time, and that is S equals ut plus 1/2 of AT squared. Simply substitute the values. So S is minus 20, U is 19.2 times T plus 1/2 times minus 9.8 times T squared. And T is what we're trying to find. So rearrange. Half of 9.8 is 4.9, and this is minus, so we're going to come onto the left-hand side of the equation. So rearrange to equate to 0. And then we can then solve. We can just type that into the calculator, and we solve now to get T equals 4.8. Okay, now next part of the question is to find the distance O to C. And just before we do that, let me just give you this in a few more decimal places so we don't have any rounding errors. So the actual answer is 4.769, which then obviously rounds to 4.8. So to get the distance O to C, we're now going to look at the horizontal. We now know what the time of the projectile's motion is from here up to here and then down. But we know that the horizontal speed is 25.6. We assume there's no wind resistance, so this horizontal speed remains constant. So in part B of the question, this is part A up here, we can say that the distance is equal to the velocity times time, and the velocity is 25.6 times the 4.769, and that gets me 122.1 meters. Now, in part C of the question, we had to find the speed of the component when it was at B. So basically, we're trying to imagine that we've got a tangent down here, and we're trying to find the speed at this point here. So what we need to do is we need to find basically the vertical component. We know that the horizontal component is going to be the same. So we know this value here is 25.6, and essentially all we're trying to do now is find this vertical component, and we know that this distance is 16, so we know that we are 4 meters down from our datum line that we defined at the beginning of the question. So our displacement is -4. So we just again go back to our equations of motion: U, V, A, S, T. The initial velocity is, as it was before, is 19.2. V is what we're trying to find in this case. The acceleration is -9.8 because it's going down, and the displacement is -4. So we now want an equation that links these things together, and that is now going to be v squared equals u squared plus 2as. So v is what we're trying to find. The initial velocity is 19.2 plus 2 times -9.8 times the displacement of -4. So I've got a minus times a minus, which gets me a positive. And so now all I've got to do is work this out now. So that gets me now v squared equals 447.04, which means that v is equal to 21.14. So if we come back up here, so I've got 25.6 going along here, and now I've got 21.14 coming down the way, so 25.6. Okay, so we're after the speed. So the speed now is just the Pythagorean addition of the horizontal and the vertical components. So the speed is equal to the horizontal component, which is 25.6 squared plus 21.14 squared, and the square root of all of that, and that gives me 33.2 meters second to the -1. The last thing we had to do was to find the angle theta, and here the angle that we make with the horizontal, and this is basically just simple trigonometry. So tan of theta is the opposite divided by the adjacent. So if we come down at the bottom here, this is part D. So tan of theta is equal to the opposite, which is 21.14, divided by the adjacent, 25.6, which means that theta equals 39.6 when we stick that in the calculator. Okay, so just quickly to summarize, so we are splitting this problem up to look at the vertical component first. which we use to find the time going from O to C. That was part A. We use the answer from part A along with the horizontal components to find the distance of O to C. Then we had to look at this particle B. So we looked at the displacement, the vertical displacement, which was -4. We used v squared equals u squared plus 2as, substitute the values in to get v, from which we can then find the velocity, or so rather find the speed, using the horizontal and the vertical components to get the overall speed, and then find the angle that we make with the horizontal.